Hey John, welcome to Plant 1 here at DECO Boat Lifts in Safety Harbor, Florida.
We are on the west coast of Florida today here at ShipShape TV. We're just outside of Clearwater, kind of across the bay from Tampa. And who we now have on the program is one of the engineers at DECO Boat Lifts. This is Chris and Sal. So much engineering and inventing has taken place in this company going all the way back to 1959. And Chris, this is your specialty. You're like a mastermind when it comes to this. What are some of the items or some of the products that you've created to really put a DECO boat lift ahead of anybody else that's out there? What are some of the things that you've engineered and invented over the years?
So what we've always been known for is we manufacture our own gearbox in-house from raw materials.
Right.
And from there, we patented our cable retention system. That was another feature that
George
we did.
was just telling us about that. That is awesome.
Right.
Okay,
Right.
It keeps the cable from crossing, so it doesn't weaken it to where it could snap.
Right.
Which is awesome.
And we're one of the only boat lift companies in the world to manufacture all of our lifts out of a box beam aluminum construction.
Okay, what does a box give you versus like a round beam?
So a box beam, or compared to where you're using like a C-channel or an I-beam, which is industry standard, box beam has two stanchions in the vertical direction and two stanchions in the horizontal direction. So it gives you bilateral support, so it's not as prone to twisting when you max load it.
Okay, so like an I-beam where you just have a center column and you have a sandwich up on top, that could possibly twist. Or
it has the weakness is it doesn't do well in twisting, and sometimes you get forces on a boat lift when the wind pushes the boat left and right in the slip. Absolutely. It gets a little left and right.
Okay.
And what happens is the I-beam weakens over time as it twists, whereas the box beam, it doesn't twist.
My house, I have what's called a low-profile lift. Okay.
The beamless.
It's a beamless lift, and you guys literally created this is an entirely invention from DECO Boat Lift.
Yeah. So the 4-motor beamless lift, we came up with that idea back in the early 2000s, and we engineered it to be a good-looking, strong, engineered lift.
Okay, fantastic. Now you invented and kind of, you've done all the engineering for all of this apparatus behind us, and this is a welding set. How many different welding bays do you have here?
So we have 7 full-time welding bays within our welding facilities. And what we ended up doing was we took all of our heavy equipment and moved it up onto boom arms so that all the equipment was off the floor, so the welder could focus on welding and not moving heavy equipment.
Okay, now the arms fold, and that gives the welders what capability?
So it knuckles in the middle, so it gives the welders the capability, if they have to weld in a tight spot, they can bend the boom arm to get in that tight corner, or if they have a long 40-foot beam, typical to our boathouse.
Oh yeah.
What you get is you can extend that arm out so they can still weld 20 foot away. Okay,
so you engineered kind of the apparatus to help with space and to get into ergonomics, okay, if you will, and that's key. But where the real brainchild has come into this apparatus is actually what you've engineered into it to make a better weld, okay? Can we talk about that? Because that's the important stuff.
Right. So we did a lot of research in early 2019, and the equipment that we purchased features state-of-the-art nanotechnology processors. Right. So it gives you better arc and better stability within that arc.
Now you're like the first to have this kind of stuff. What is that helping in?
So it helps basically avoid porosity, and porosity in a weld is very bad.
Isn't porosity the kind of the trash that's in a weld?
Impurities, as they call it.
Right.
Impurities in the weld. You get pitting, you get weld fatigue, and you'll get weld cracking, which leads to weld failure.
Now, Chris, I'm much of more of a creative person rather than somebody that could come up with the engineering to design something like wave pulse. Okay, I have no idea what it is, but you sure do.
Right.
And how did you engineer wave pulse into the system?
So all of our welding equipment had to have things such as hot start. They had to have things such as DC wave pulse. They had to have variable wave pulse frequencies. And what that does, it allows our welders to really control, basically the dig and fill of the material, so you get good penetration. You can control the heat output. Okay. And we get a strong, beautiful looking weld.
Okay, so that has something to do with heat, with controlling?
You want to control the heat input, that's correct.
And that's what that does.
Correct.
I know there's a lot of stuff here that you masterminded that's totally proprietary. and everything. But if people do have more questions, you can't get a final list than at DECO. Where can we think?
Sure. We have a great website at decoboatlift.com.
All right.